Yes.
That quiz thing you did, or you handed out,
Mm-hmm.
is that due tomorrow? What is
If you're going to do that, you have, I think, until Thursday. Read your email.
that? The quiz starting?
Read your email. Read your email.
Yeah.
All right. So, what we have here is we've calculated the moles in your homework. You calculated the moles of scandium carbonate. And you also have I've calculated and written here, if you wrote out the equality statement, or if you didn't, you see now that you should. I showed you how to do it yesterday, included that, but even if you didn't do it yesterday, I hope you're seeing that you all have an equality statement here now. An equality statement is simply where I have one measured or calculated value equal to some other measured or calculated value. You can't make these up, okay? They actually have to be something that's real, not just made up stuff. And we know it's not made up because we actually did the calculations to get this number, okay? And we did it properly. So now that I have an equality statement, I can take moles of scandium carbonate and using this equality statement, convert that into grams of scandium carbonate, okay? So let's see how that would work. That means that this becomes a new starting amount, okay? So I'll put that over 1. 2.42 moles of scandium carbonate over 1, because our starting amounts always go over 1. To convert that into mass, I need an equality statement like this. Okay, what I need to do is to take one side or the other of this equality statement. Choose the side whose units and species match my starting amount, or your starting amount. Well, our starting amount have units as moles and a species of scandium carbonate. This side of the equality statement has the same units and species. That means this whole side of the equation goes under this fraction. Okay? 1 mole of scandium carbonate. Okay? Then the other side of the equality statement will go on top. 269.95 grams of scandium carbonate. Okay? Now all we have to do is to cancel units and species, and we have what we're looking for in this case, grams of scandium carbonate. All I have to do is the correct math. And when I have two things on the top of fractions like this, what math operation do I use? Multiplying. So please get out your calculators and let's do that. Do that with me. Okay, now that's grams of scandium carbonate. 2.42 moles of scandium carbonate will have that many, will equal that many grams. Okay? Now I still have to round off. How many digits do I need in the final answer? 2. This number has 3 total digits. This is multiplication and division here.
253. I got 6, or not 253, 653. I only got 650. You tried something in wrong.
Let's see, 2.42. Oh, I'm sorry. Now, how many significant digits do I need when I'm doing multiplication and division? To look at the total digits for all the measured and calculated numbers. And the one with the least digits is the same number of digits we need for our final answer. So this one has 3 digits, yes. This one has 5. These are counting numbers. They don't really matter to us as far as figuring out significant digits, because counting numbers are infinitely significant. So this one has the least digits. That's how many digits we want our final answer. So after the first 3 digits that are significant, we're going to underline everything else. Draw an arrow to show that we are rounding off. And then we have 653 grams of scandium carbonate. Okay? So that's how we're going to use molar mass. Okay? You calculate the molar mass this way, show the equality statement with all the units and species, and then you can use it to build a conversion unit to go from moles of something to mass of something. Now we can also use it to go from mass of something to moles of something. Okay? Alright. So let's come up with a new problem and see how that works. Let's see here. Let's do this. To go from one species to another, you must use a molar ratio. Okay? We are going from magnesium hydroxide to water. So we're going from one species to another. So we must have a molar ratio. Where does the molar ratio come from? Balanced equation. Okay? A molar ratio has moles on the top, moles on the bottom. So what we have to do in this problem is we're starting with mass in grams. We're going to convert mass in grams to moles. Once we have it in moles, then we're going to convert to the second species, which in this case is water. We'll have converted that into moles of that second species, so we've got to have molar mass then to convert it into mass again, because the question asks how many grams do you expect to have. Okay? To go from mass to moles, we need a molar mass. Okay? To go from moles to the second species, we need a molar ratio. And to go from that second species, which will be at that time in moles, we're going to have molar mass for the second species. So this is our first species here. And this over here is going to be our second species. Okay? You might say this is a solution map. I just drew out how I want to get from A to B. Okay? It's like having instructions. Go to Google Maps, put in where you're starting from, where you're going to end to. It'll give you a set of directions if you ask it. All right? Anybody ever done that? Yep. Okay. All right, now, I'm going to do this one step at a time. And then I'm going to show you how to do all the steps at one time. Okay? You with me? So our starting amount is 2.75 grams. And we know to go from one species to another, we've got to get this into moles. Okay? So we're going to have a molar mass calculation. Magnesium hydroxide, Mg. Magnesium has a 2+ charge. Hydroxide has a 1 negative charge. So magnesium hydroxide is MgOH2. Starting amounts go over 1. Okay? Alright, now to get from mass to moles, I've got to have the molar mass of this species. So we need the mass of magnesium, the mass of oxygen, and the mass of hydrogen. Doesn't matter. You could do it first. I said I'm going to do it one step at a time. Okay? So magnesium we have listed on your periodic table for the test anyway is 24.30. Yeah. And we only have one of those. Oxygen on your periodic table for use on tests is 16.00. And we have two of those. Now remember, this is just like adding 16.00 to itself twice. So we're going to keep both zeros after the decimal, okay? So 2 times 16 is that right? And your periodic table for testing, it shows the atomic mass, average atomic mass or relative atomic mass for hydrogen 1.008. We have 2 of these. So that's 2.016. Now that means we have 2 empty slots over here. Now we are going to have to round off. So we're going to have 6 and 1 and 3 and 8 and 5. We're going to underline the 6 because it's going to be rounded off. Okay, we know that this is, well, let's go ahead and round it off here. Let's just do it the fast way here, just quickly. 58.32 grams of magnesium hydroxide. And for this class, you're always going to say it's equal to 1 mole of magnesium hydroxide. Okay? When you get to AP, you don't have to do that. You stop right there. Okay? But for now, I want to emphasize where we're getting these ratios from, where we're getting these conversion units from, and that's from the equality statements. So that's why we're doing this. So then, matching the units and species with one side or the other of this equality statement, I can see that this has the same units and species as the starting amount. So this number with its units and species goes on the bottom. 58.32 grams of magnesium hydroxide. And the other side of the equality statement goes on the top. 1 mole magnesium hydroxide. Cancel units of grams and the species magnesium hydroxide, and I'm ready to calculate the moles of magnesium hydroxide. Okay? So practice with me. Use your calculator and practice with me. Okay, and that's going to be moles of magnesium hydroxide. I'm going to underline all of the insignificant digits. We only look at the measured numbers like this and calculated numbers like this. This has the least digits, so I need the same number of digits as my final answer. Leading zeros are not significant, so this is my first significant digit. 1, 2, 3, 1, 2, 3, and underline everything else. Draw an arrow, and we'll do 0.0472 moles magnesium hydroxide. Okay? Now that's just the first step. We've got it in the moles. We're right here. Okay? We've just crossed into the city limits of Moleville. Okay. All right. Now we have it in moles. We have we're going to need a balanced equation to get it from this species to the one we're looking for. Okay. So let's do that. The equation says we're reacting magnesium hydroxide. I'm sorry. The problem says we're reacting magnesium hydroxide with hydrochloric acid. Hope you know how to write the formula for hydrochloric acid by now. Okay, that was a couple of units ago. We learned to write the names of acids and the formulas for acids. Huh? We need to know the physical states. Hydroxides generally are insoluble. There are a few exceptions, but magnesium is not one. So this is a solid. Hydrochloric acid, just about every case so far, we would assume an acid to be aqueous. In fact, there are, when you're doing certain kinds of equations, certain acids would not be considered aqueous, but this one always is because it's a strong acid. So it's aqueous. And we'll get to that when we get to the acids chapter in here, or acids unit. So now we have to figure out, well, what products do we want? Well, this is a two-part compound. This polyatomic ion here tends to stay together. So this is a one-part and two-part compounds. And that means it's most likely going to be double replacement, where the first part of this goes with the back part of that, and the front part of this goes with the back part of that. We have no subscripts that are going to travel. This subscript right here is not part of the polyatomic ion, so it doesn't travel. And the only subscripts that do travel are those that are part of a polyatomic ion. So we're simply going to take magnesium and put it with chlorine, at least to start with. We'll figure out how to balance it in a minute. And then we're going to put the H with the OH. And there's our water. Okay? So what physical state do you show for water when it's an acid-base reaction? A liquid. Okay? We need to figure out how this is going to come out. So magnesium has a 2+ charge. It's in column 2 of the periodic table, so it has a 2+ charge. Chlorine, or chloride here, in this binary compound, is going to have a 1- charge. You know that because it's in 7A, the column 7A. And in binary compounds, those have a 1- charge. So you need one of these and two of these. Okay? Chlorides generally are soluble. There are some exceptions. Magnesium is not one of them, so so this must be aqueous. Okay, so now we've got balanced formulas. We need to balance the equation. I'm going to list our elements in a column here: magnesium, oxygen, hydrogen, and chlorine. Got 1 magnesium to start with, 2 oxygens to start with. Now hydrogens, I've got 2 here and 1 here, so that's 3, and I have 1 chlorine to start with. Over here I've got 1 magnesium, I have 1 oxygen, 2 hydrogens, and I've got 2 chlorines. Okay, we always want to try to balance oxygen last, hydrogen next to last. So I need to start with the chlorines. Since I have 2 on the right, the way to get 2 on the left is to put a coefficient 2 in front of the species that contains the chlorine, and that's this one, the hydrochloric acid. That's going to change the number of hydrogens and chlorines. So now I have 2 hydrogens here, 2 here, so I have 4 hydrogens. Alright, am I moving too fast for anybody? Please speak up, raise your hand, say so. Don't let me leave you behind, okay? Alright, and then I have 2 chlorines. So let's see, the magnesium is balanced and chlorines are balanced. So now I have to go to hydrogen and oxygen. I want to balance the hydrogen first. Hydrogen is next to last. To get 4 hydrogens on the right, I need a coefficient 2. Changes the number of oxygens and hydrogens. So now I have 2 oxygens and 4 hydrogens, and the equation's balanced. With a balanced equation, I can write a molar ratio to change this species from moles of this species into moles of the second species. Okay, so this becomes a new starting amount. 0.0472 moles of magnesium hydroxide. And I'm going to put that over 1 because this is a new starting amount. Okay, I go to the equation and I find the coefficient in front of magnesium hydroxide. There's an implied 1 here. I need to match the units and species with this, the top of this fraction with the bottom of this one. This becomes 1 mole of magnesium hydroxide. Okay? Now then on the top, we want the species we're looking for in the end. The problem says, how many grams of water would you expect to produce? Well, water, there's 2 waters in the equation, which equates to 2 moles of water. Okay? And you can write it as H2O if you prefer, it doesn't really matter. So to do this math, we just simply have to multiply this number by 2. Oop, I put my calculator wrong. So 0.0944. Cancel the units. Cancel the species. And I can see I have what's left is moles of HOH. And there's no reason to round it off because this number and this number have the same number of significant digits. Okay, we're not quite there yet because the problem asks you for grams of water. Okay? This number we just came up with is going to become a new starting amount. We're right here. Okay, we have the moles of the second species. There's our second species. Now we've got to convert it into mass, so we need molar mass. Only this time we need molar mass of water. Alright, so starting with this starting amount then, 0.0944 moles of water. Put it over 1, and I need molar mass of water to convert it into grams. Okay, I've got 2 of these hydrogens, 1 of these oxygens. So I get 2.016, and I get 32. And I've got an empty slot under the 6 here. 34.016. Since that's an empty slot there, the 6 gets rounded off.
I thought it was 32.
Oh, I don't know why I did that. I was thinking about where I multiplied by 2 a while ago. Duh, thank you for catching that. 16. Okay. Let's go back and do that again. So that's going to be 18.016. We still underline that last digit and round it off to 18.02 grams of HOH equals 1 mole of HOH, or H2O. Okay? Where do the moles go? What? Where do the moles go? On the bottom. Just don't put it in your yard. 1 mole HOH, because I want to match the units and species in the top of this previous step. The other side of the equation goes, other side of this equality statement rather, goes on the top. 18.02 grams HOH. Cancel units, species, and multiply. To what? To what? Oh, but we took care of that in this ratio, in this molar ratio. There's our 2 moles. When you do molar mass, that mass you calculate is always 1 mole. So that's a very common misunderstanding. So let's make sure we're as clear about that as we possibly can be today. Okay? When you're calculating molar mass, the mass is always equal to 1 mole. When you're calculating molar mass, the mass is always equal to 1 mole. You don't use the coefficient in the balanced equation. That's used only in the molar ratio. Okay? All right. So let's see. 0.0944 times 18.02, and I get 1.701088. I need to round off to just 3 digits here. This one has 4. That's a calculated number. This is a measured number. Those are the only 2 numbers we're going to use for figuring out significant digits. We want 3 significant digits. So we underline everything after the first 3 digits and round it off. So we get 1.70 grams of water. And that's the final answer for our problem. Yeah, well, there are some problems in here where you have to do this 3 times and then do some other calculations. Okay, get to that. Plenty of time to work. You're going to fill up, depending on how big your writing is, 1 to 2 or 3, even 3 sheets of paper on some of these problems. You're going to be amazed that you can do it. You're going to say, wow, when you get to the end of the unit. Okay, all right, now, I promised you that I would show you how to make this a little bit faster. Can't make it a lot faster. I can make it a little bit faster. Would you like to? This is one cut that I will let you do. Okay? Camera's frozen. I put everything else. Let's just